Alright, so now we're here at the last problem for tutorial 6. In problem 5, we have a block diagram again. So this time round we have a nested block diagram. In the inner loop we have a system with a negative feedback, and then in the feedback loop there is an integrator, and then also there's another block over here, and on top of everything we have another negative unity feedback. So basically this is our system over here as a block diagram with two feedbacks, the inner loop and the outer loop, and then we have the input and output. So first part of the question is asking the closed loop transfer function and also the system type. And second part of the question is asking what is the steady state error for an input of 5 UT and another input 5T UT. And then in this case, UT is equal to 1, which is a step input. And then also discuss the validity of the steady state error that we found. And let us first solve the first part of the problem. So in the first part, we have to find the closed loop transfer function, and it's actually pretty straightforward and pretty easy. First, just simplify the inner loop and then simplify the outer loop. So in the inner loop, what we have is forward loop transfer function, which is 1 over s squared multiplied by s plus 1 divided by 1 plus open loop transfer function, which is this term multiplied by that term. So we have 1 over s cubed multiplied by s plus 1. And simplifying this term, what we get is s divided by s cubed multiplied by s plus 1 plus 1. So this is basically our inner loop block diagram. And in order to visualize things more easily, I can actually replace the inner loop. Let me grab another pen real quick. So the inner loop is basically given by the green shaded region. And what I can do now is substitute this green box with the inner loop transfer function that we obtained over here. So I have s over s cubed multiplied by s plus 1 plus 1, and then this is connected to the second block, this block, 1 over s squared multiplied by s plus 3, and then we have a negative unity feedback on top of each other. And of course, if we have something like this, it's easier for us to solve the closed loop transfer function, which is C of s over R of s equals to forward loop transfer function divided by 1 plus open loop transfer function. So what we have is one over s multiplied by s plus 3 multiplied by s to the 4 plus s to the 3 plus 1 plus 1. So basically this is our closed loop transfer function. And then the first part of the question is also asking for the system type. And in order to see the system type, we need to look at the open loop transfer function or the for loop transfer function instead of the closed loop transfer function. So this is very important. System type is always referring to the open loop transfer function. And the open loop transfer function in this case is S over S cubed multiplied by S plus 1 multiplied by S squared and S plus 3. So we can cross this S at the top with this S at the bottom, and we're left with only one integrator. So the system type is a type 1 because there is one integrator in the open loop transfer function. And next, we have to solve for the steady state error given two different types of input. I'll start off with a fresh piece of paper. So in this part, I'm going to use the express method to solve for the steady state error. And we have a type 1 system. So for the first input, we have RT equals to 5 UT. And UT is actually a step input. So this is a step input. And then the steady state error for a step input of a type 1 system is given by 1 over 1 plus Kp. And because it's 5 of the step input, we can treat the steady state error or the step response as 5 times the original single step input. So just multiply steady state error with 5. And Kp is the static position error constant, and it's given by the formula limit of G as S tends to 0. And G over here is our forward loop transfer function, which we have found previously, and it is equal to 1 over S multiplied by S plus 3 multiplied by S cubed times S plus 1 plus 1. So this is our Kp, and plug in S tends to 0 into the limit equation, we get Kp equals to infinity. So steady state error will tend to 0 because Kp tends to infinity. And then for the second type of input, we have R of t equals to 5t multiplied by ut. And then a multiplication with t in the time domain corresponds to a ramp input. In the Laplace domain. So basically this is 5 of a ramp input to the system. And for a type 1 system, given a ramp input, the steady state error is equal to 1 over kV. And since we have 5 over here, we can just multiply the error with 5. And kV again is the static velocity error constant with formula given by limit of S multiplied by G as S tends to 0. So just plug in G into this equation again, and solving the limit, we will have kV equals to 1 over 3. And so the steady state error is 5 over kV, and that is equals to 15. So we get the steady state error equals to 0 for the step input and steady state error equals to 15 for the ramp input. And the question is asking us basically to discuss the validity of the steady state error. And actually, if we want to find whether the system or not using pole zero location or Routh-Hurwitz table, we can find that the system is actually unstable. So system is unstable. This can be proven by Routh-Hurwitz table. And if a system is unstable, the steady state calculation is no longer valid because an unstable system does not have a steady state error. Instead, the final values of the response will go to infinity. So our steady state error calculation is in fact invalid. So those are all the problems for tutorial 6. Hope you enjoyed the videos, and please let me know if you have any questions. Just drop me an email or come to my office hour. So as I mentioned before, it's pretty important to ask questions. I know that this class is pretty hard, but eventually, if you understand everything, it will not be that hard anymore. So those are all for tutorial 6. I might upload another video that basically recaps the conceptual things for this tutorial. So thanks for watching, and just let me know if you have any questions.